Okay, so lesson 2.7, it's solving equations. If you want to get technical, I'm not sure how much of a pre-calc standard today is. Okay, it's solving equations. Notice it says solving equations in one variable. We are going to talk about those extraneous solutions, which you've talked about before. So honestly, I feel like this is more probably of an algebra review, but I also feel like it's a good review because solving equations, they come up, we need to be able to deal with these fractions. So as we look at example 1, x plus 3 over x equals 4. Thoughts on how you want to solve that?
You have to multiply both sides by x.
And why would we maybe want to multiply both sides by x?
Because x is the complicated.
Yeah, we want to get rid of that fraction, right? So think about when you see fractions, which notice they all have fractions today, right? That's the whole plan. When you see fractions, we want to get rid of those fractions. So if it's divided by x, we're going to multiply by x. If we multiply by x, now keep in mind that means technically we're multiplying both sides of the equation by x, right? On that left, we're going to take the x and we're going to have to distribute. What is x times x? X squared plus, what is x times 3 over x? Just 3? Because if you need the visual, what's the visual? X can be a fraction as being x over 1. And so you multiply x over 1 times 3 over x, the x's cancel, and we have a plus 3 equals. On the right, it's not just 4, it's 4 times x, which is 4x. Okay. Thoughts on where to go from here? I have x squared plus 3 equals 4x.
Bring that 4x to the left side.
Okay, make our equation equal to 0. Because there's an x squared term, an x term, and a constant, make our equation equal to 0. I agree, so we'll subtract the 4x over. When I subtract that 4x over, I'm going to land it in the middle, so that I'll be in my quadratic form of x squared minus 4x plus 3 equals 0. So again, making it equal 0 because there's x squared and x terms. Now what's our solving technique? We have a quadratic equation equal to 0. Factor. We're going to hope it factors, right? There's a backup plan if it doesn't factor, but this one should factor. So there's no GCF. 2 parentheses. X squared is x times x. What multiplies to be positive 3, but adds to be negative 4. It's got to be 3 times 1. And my signs are minus and minus. Negative times negative is positive. Negative 3 plus negative 1 is negative 4. Okay, now what? We have 2 factors multiplying to equal 0. Yeah, 0 factor product property says 2 items multiplied equals 0 instead of each equal to 0. So x minus 3 equals 0 or x minus 1 equals 0. And obviously you do the solving and we get solutions of x equals 3 and 1. Before we move on, let's talk about a couple of things. First of all, the fact that my title said involved extraneous solutions. Extraneous solutions means, might there be extra solutions that don't work? There might be. Okay, so you want to be in the habit of checking. Checking can be kind of a quick look at it check. could be an algebraic check. It could be a graphic check, a graphical check. Okay. Now, in this one, what value would not work as an answer? Like if we look at the original equation, what value do we know for sure could not be an answer? Since there's x in the denominator here, that means x could not equal 0. Did we get 0 as an answer? No. So, to be honest, likely they work. I'm going to just kind of demonstrate, just because I want to talk about the different checks today. On this one, besides what we just did, is just doing that quick visual check, but I just want to demonstrate real quick how we can check these algebraically. And algebraically is just, you guys have been trained to do this for years, taking those answers and putting them into the original problem. So if I use 3, for instance, the original problem was x plus 3 over x. So 3 plus 3 over 3, does that equal 4? And at that point we know 3 plus 1 does equal 4. Okay, and I get it. You can do this in your head, right? You don't have to write it down. I do this in my head most of the time. I just want to kind of revisit, hey, this is a good way to check. If we do the same thing with 1, it's 1 plus 3 over 1. And the question is, does it equal 4? Well, 1 plus 3 does indeed equal 4. So again, be in that habit of checking your answers today, somehow or another. To be honest, the original check of, oh, well, 0 would make that denominator 0, so it can't be 0. That's probably going to be sufficient on some of these, but not always. Okay. Questions before we move forward to 2? Okay. Let's move forward to example 2 then. X plus 1 over x minus 4 equals 0. Thoughts on how to solve? There's a denominator again, isn't there?
By x minus 4.
Okay. We have one denominator, it's x minus 4. So you're multiplying by that factor of x minus 4. Now, keep in mind, we're doing that to both sides of the equation, right? So I'm multiplying the left by x minus 4 and the right by x minus 4. We're going to take that x minus 4 and we're going to distribute it. So the first thing I'm going to have, and I'm not going to quite multiply it out, but I'm going to do x minus 4 times x. So I'm just going to write for a moment x times x minus 4. I'll come back and multiply that out next step. Or feel free to multiply it out right now, that's fine. Plus, what happens when I multiply x minus 4 times 1 over x minus 4? Those x minus 4s, we can make that x minus 4 over 1 if you prefer. X minus 4s will cancel, and we're left with a 1. On the right, what's 0 times x minus 4? 0. Okay, so we've gotten rid of the fractions. That's going to be your first main goal here. If you didn't already, what is x times x minus 4? Should be getting x squared minus 4x, and then plus 1 equals 0. How do we solve? We have a quadratic equal to 0 again, just like last time. What's different? That no one wants to admit to. We can't factor it, can we? We can't get a product of 1 and a sum of -4. So, what's plan B when factoring fails?
Quadratic formula.
Quadratic formula. You know that quadratic formula, yes? If not, you're going to look it up in your notes previously, Google it, look up the song, something, right? Okay, so I'm going to say x equals, because that's what we're solving for, negative b, so that becomes positive 4, plus or minus the square root of b squared, so negative 4 squared, minus 4, times a is 1, times c is 1, all over 2a, which is 2 times 1. Sound familiar? Okay, clean it up. I don't know if I can squeeze that in there or not. We'll try. 4 plus or minus the square root of, remember negative 4 squared, don't let your calculator tell you that's negative. Negative 4 squared is going to be 16 minus 4 times 1 times 1. So 16 minus 4 is 12 all over 2. So I have 4 plus or minus the square root of 12 all over 2. But we're going to keep going with that a little bit because my answer key is not going to have that. What do we know about the square root of 12? What perfect square does the square root of 12 have in it? 4. So it's a square root of 4 times 3, but the square root of 4 is 2. So it's 2 square root of 3. Does that ring some algebra 2 bells from you? Okay. So this really can become 4 plus or minus 2 square root of 3, all divided by 2. What do you notice about that answer? Each term has a factor of 2 that you can divide out. Or what I'm going to do in this case, since my denominator of 2 can divide into both pieces, I'm just going to do that. What's 4 divided by 2? It's 2. Plus or minus, what's 2 square root of 3 divided by 2? The 2's outside will cancel, leaving us with square root of 3. So 2 plus or minus square root of 3. Okay. We got to talk checks before we move on. What are your thoughts about a check here? Do you want to do an algebraic check like last time? Not really, do we? Okay. Now, and as you just do a quick visual check, 2 plus square root of 3 and 2 minus square root of 3. What would you guess? They're likely going to work. Because what's the answer we know can't work? 4. Because 4 minus 4 would make a denominator equal to 0. But while we're here talking about checks, okay, if we don't want to check algebraically, we don't want to have to plug that back in. Which you can, with the use of a calculator, it makes it pretty easy. But what are your thoughts if I suggest that we try checking this graphically? How would we check this graphically? I mean, obviously using our calculator, but what are you doing to confirm this graphically? Where are the solutions to a problem on the graph?
When y equals 0.
Okay, when y equals 0, right? They are on your x-axis. Those are your x-intercepts. And so in order to check this graphically, which is what we're going to do next, we're going to graph the equation. Now, in order to graph this equation, basically it has to be equal to 0, which we already have it equal to 0. So you're just going to graph y equals x plus 1 over x minus 4. And then after you graph that, you're going to check the zeros. Okay? So grab your calculator if you haven't already. And let's check this out real quick. I'll get there up on the screen. So if I go and graph, there we go. What do we say? Y equals x plus, I'm going to do a fraction bar, 1 over x minus 4. If you don't do a fraction bar for 1 over x minus 4, make sure x minus 4 is in parentheses. Okay? I'm going to graph this. Okay? Well, there's a good thought. I've got two answers, right? As you look at that graph, you've got two places it's crossing the x-axis. My suggestion is if you hit trace, or if you go into second calc and do value, one of our zeros is 2 plus the square root of 3. So if I type in 2 plus square root of 3, and notice if I hit equals, it gives me a 0. That means that is one of my zeros. If I repeat it and do 2 minus the square root of 3, notice again it gives me a 0. Okay. You could also find your zeros, couldn't you? You could use that second calc, you could find your zeros and make sure the decimal matches up. But that's how you check. There we go. That's how we're going to check graphically, is you check the zeros. If I find out my zeros are x equals, it was what, 0.268 and 3.732. And the key is they match up with that. Okay? So it checks. But the key is to check your zeros when you check graphically. Again, I know it was pretty obvious. The only answer that wasn't going to work was 4. But there are times where we need these checks. Okay. Questions here? Okay. Let's go to the next example. As you start looking at the next example, and you start looking at your denominators, right? We've got more than one denominator this time. What are your thoughts about these denominators and what we're going to have to do?
Do you like factor out the big one?
Yeah, we're going to hope that if we factor out that third denominator, that it matches up with the other two. Otherwise, if it's even different factors, that makes this problem just that much more complicated. But this problem is designed to be nicely solvable, which it should be. This x squared minus 4x plus 3 should factor x and x. Multiplying to be 3 has to be 1 and 3. If it multiplies to be positive 3, same signs. If it adds to be negative, both negatives. Oh, did that happen to match up? It did. Okay, I'm not going to say it's always matches up, but it definitely happens to quite often. Okay, so thoughts? I have denominator of x minus 1, x minus 3, and then x minus 1, x minus 3. What do I do? How do I get rid of my denominators here? What am I going to have to multiply by? What is my, and remember, if you remember from algebra, I always said, okay, what would be your least common denominator? What are the common factors? There's a factor of x minus 1. There's a factor of x minus 3. Does that take care of all of my denominators? And it does. Okay, so we're going to multiply by x minus 1 and x minus 3. That means, of course, that we're multiplying both sides by x minus 1 and x minus 3. Obviously, if you need to, think of it as x minus 1, x minus 3 over 1. Okay, starting on the left. What happens when you take x minus 1, x minus 3, and you multiply by 2x over x minus 1? What happens here? X minus 1 will cancel with x minus 1, leaving us with 2x times x minus 3. Plus. Okay, now we're multiplying x minus 1, x minus 3 times 1 over x minus 3. This time the x minus 3 cancels, leaving us with the x minus 1. If you want, you can say 1 times x minus 1. But really, it's just an x minus 1. And then on the right, what happens on the right? 2 over x minus 1, x minus 3 times x minus 1, x minus 3. Everything cancels except 2. And now it seems like magic, but we have a equation without fractions. So of course you're going to start and you're going to distribute 2x squared minus 6x plus x minus 1 equals 2. Then we're going to want to make this equation equal to 0, because I have x squareds, I have x's. Anytime I have x squareds and x's, you're usually making it equal to 0. So if we make this equal to 0 and clean it up at the same time, are you guys that talented you can do that with me? To make it equal to 0, we need to move that positive 2, which means I'm going to subtract 2. And then clean up your like terms while you're at it. So 2x squared minus 5x minus 3 equals 0. What are your thoughts on solving this one? What do you say, Ethan?
Product of AC.
Product of AC. It does factor, folks, if you want to go the route of product of AC. There is an A value, so you can't just automatically go to parentheses. Your other option is, if you're not a fan of product of AC, quadratic formula still works. Okay? However, I'm going to go with product of AC because we probably need to review it, don't we? I feel like every time I get a chance in pre-calc to review product of AC, I need to. So if we do product of AC, that means I'm doing product of 2 times negative 3, which means I need a product of negative 6, and a sum of B, and B in this case is negative 5. What multiplies to be negative 6 and adds to be negative 5.
-1, 6.
except I'm going to make it 1 and negative 6. Because you said it the other way around, I think.
Yeah.
Or I heard it, I don't know. But yeah, since it multiplies to be a negative, I'm going to have to use the 1 and 6 option because I need to subtract to be the negative 5. So 1 and negative 6. What do I do with that 1 and negative 6 or negative 6 and 1? When it's product of AC, we take the middle term and we split it. So let's ring some bells. Dig deep. So let's see. Which way are you guys going to do this? You want plus 1x minus 6x or other way around? Or does it matter to you guys? I'm going to say minus 6x plus 1x. I've got to drop down the 2x squared. I've got to drop down the minus 3 and make it equal to 0. Remember, you're doing GCF of the first half. So GCF of the first half, 2x squared and minus 6x. We can factor out GCF of 2x. 2x squared divided by 2x leaves me with x minus 6x divided by 2x leaves me with 3. What about a GCF between 1x minus 3? If all else fails, there's always a GCF of 1. And I am going to write that. So I'm going to write a plus 1. When I factor out my positive 1, I'm left with x minus 3. Parentheses match. Remember, that's the good thing. That's what we want to happen. So one of my parentheses is the matching parenthesis of x minus 3. When you take out those matching parentheses of x minus 3, the other pieces that remain are 2x plus 1. And then we can set each part equal to 0. X minus 3 equals 0, or 2x plus 1 equals 0. We get x equals 3, and subtract 1. We end up with, divide by 2, negative 1/2. Don't forget to check your solutions. What do you notice on this one? Do they both work? No. There's an obvious one that doesn't work. Which one obviously doesn't work? 3 can't work. 3 can't work because if you put it back in the original problem, it makes the denominator equal to 0. So 3 can't work. So that means the only solution we have left is negative 1/2. Okay? You could check it algebraically. You could check it graphically. If you check this one graphically, you would want to take this original equation and make the original equation equal to 0. Okay? You don't want to go after you've multiplied and gotten rid of the fraction. So you'd want to have like 2x over x minus 1 plus 1 over x minus 3, and then minus that 2 over x squared minus 4x plus 3. Okay? Again, once you see something makes the denominator equal to 0, though, that's a pretty good check. Okay? One more? Definitely need to talk about the beginning part on this one. Okay, x minus 3 over x plus 3 over x plus 2 plus 6 over x squared plus 2x equals 0. Okay, what kind of things do you notice here? What do you notice about the denominator of x squared plus 2x? X squared plus 2x has a GCF of x. So if you factor a GCF of x out, then you're left with x plus 2. And of course, it's just pure coincidence that that matches with my other denominators, right? So what is the GCF we're going to multiply everything by? Not GCF. Least common denominator. What's that least common denominator I want to multiply everything by? First one, there's a factor of x. The second one, there's a factor of x plus 2. Realize those are different things, right? Those are different factors. So x, x plus 2. The last one just so happens to be x and x plus 2. So what can I multiply everything by? X and x plus 2. Okay. On the first fraction, x cancels. And so now, and I guess you can put this over 1 if you want. If x cancels, I then have x plus 2 times x minus 3. Plus the second fraction. X plus 2 cancels with x plus 2. So I have 3 times x. Plus the last fraction. X and x plus 2 cancel, so I'm left with my numerator of 6 equals, on the right, 0 times anything is 0. Okay. What do I have to do with x plus 2 and x minus 3? We're going to have to distribute or FOIL. So x squared minus 3x plus 2x minus 6. And we still have a plus 3x and a plus 6 equals 0. Okay, I like the way this cleans up. It cleans up nicer than I anticipated. Carry the x squared down. Minus 3x and plus 3x cancels, leaving me a plus 2x. Minus 6 and plus 6 cancels. I have x squared plus 2x equals 0. How do I solve this? X squared and plus 2x has a, what's the word there? GCF. There's a GCF of x. So if I factor that x out, I'm now going to have x plus 2. So x times x plus 2, of course, set each part equal to 0. So x equals 0. X plus 2 equals 0. We get solutions of 0 and negative 2. And don't forget to check. What happens when we check? Oh, neither of them work. We had the denominator of x. That means x can't equal 0. We had a denominator of x plus 2. That means x can't be negative 2. If neither of them work, what's that mean? Our answer is no solution. And that does happen sometimes. Okay? To be honest, off the top of my head, I can't remember if it happens in your homework because I didn't look at the homework this morning, but okay. Your homework. is on page 232. 4 through 28 evens. Okay. We did get through the notes. That does make it due tomorrow. You do have about 4 or 5 minutes, so you can maybe at least get your paper set up. Maybe start the first one, depending how quick you are.